So you want to measure half a wavelength or multiples of coax for testing the exact impedance of your antenna. So of course you'll need one of these or other makes. This is 75 ohm excuse me, satellite cable. You cannot test it coiled up like this. Must be laid out on the ground or hanging from the air if it's already connected to something and you're disconnecting it to check at the antenna, disconnecting it at the antenna to check for a half wavelength or multiples of. So that's all you need on your antenna analyzer. And short coax to your dummy load. So the dummy load goes in one side of the T and the coax goes in the other, and then just look for the dip, which I'll demonstrate to you. But first I will unwound this and show you how it's done. So that's how it's connected up. I may point out that the 75 ohm satellite cable was manually measured from a program. I'll put the link on for a coax calculator, lengths, and a very useful program. And when I heard about this idea, I quickly put the 75 ohm on and was assured that it was on my frequency I wanted. Half wave, multiples of. So there it is. It's on 4 meters, 70 megs. As you see, coming to the dip, which is just there, about 71 megs. Now 450 is our FM part of the band, which seems pretty good enough. So there's multiples of half wave on 70 megs. Wouldn't be the same on other frequencies. Look, as we turn down, but it is there, look, on 12. Certainly not on, what is it, 4 to 10 megs, but on 12 megs, oh, it was. Now it's just not moving up fast enough now. Right, so it's on 12 megs. It's multiples of half wave, but we don't know. You can find out in the program. You can actually put the length of this coax in, and you'll find a reasonable, you'll put the length of this coax in, just guess on the velocity factor, and you'll find somewhere of how many wavelengths there is in this piece of coax. But I'm only interested in 70 megs. So there it's coming up, 70 megs is multiples of half wave. Right, that's open at the other end. The other end is open. If you wanted to measure quarter wavelengths of coax, you terminate or short the other end of the coax. Now I'm not going to trim any coax because it's so expensive, and for demonstration purposes I'm sure you'll understand. But if the multiples of half a wave were, say, at this frequency, then it would require snipping from the other end. Small snips at a time. You can get a little bit excited and think, oh, I'll take 2 inches off this time, and then it's just too much. Waste of coax, throw it away, or use it on another frequency. But if it's higher than what you want, like that, it means it needs extra length on the end. So this is no good. Find something a little bit longer so you can snip off. This is to find your exact impedance at the antenna. You can either go to very close to the antenna and check for impedance, but that's impractical, really, isn't it? So you need to be a fair distance away from your antenna, but you want to know the exact impedance at the terminals of the antenna, and the only way to do it is have coax to this antenna analyzer in a half wave or multiples of. So I'm checking now on 50 ohms. 50 ohm cable. It's quite long actually. Doesn't matter how much length it is, as long as it's not coiled up and interfering. So this piece of length it's lying out on the floor, it does have actually on one end a choke already made on the same coax, but there it is, it's multiples of half a wave at that frequency, and unbelievably it's also near enough to use on 70 megs, and I'm 34783, so we're on there. Winding it up, and there it is, look. I have an 81-inch length of 213 there, and there's no chance on 70, of course. So let's go down and have a look. It seems to know when there is no chance. Excuse me. This antenna analyzer seems to be no chance, and it doesn't waste its time. So that's why it doesn't move. So really we have to go down frequency on another. Maybe they fix this on the MFJ or the other MFJs. You see, it knows it's there is no chance, but it will get there eventually, and I know that it's moving now. Look, so there's either one wavelength, half wavelength, half wavelength at that frequency. So I'm going to check now on the computer, measure 81 inches on the computer, on the link I've showed you for 213, and see what 81 inches comes up. Right, there's the program. There's 213. 48.5 megs was the exact one, and I put 80 inches in because the 1 inch is already in the line like the T, so you deduct the 1 inch because of the T piece. And what does that say? It says 49.34, is it? I can't see with that. 94, so that's a half wavelength of coax that the MFJ has just measured. That was a surprise. It was just a random piece of coax to me, but it did have a 259 on one end. So I should put the link of this very useful program. You'll be wondering how you managed without it. So there's the inches look, and there is the result. 49.94, a fraction under half wavelength, which is near enough. So all this on this program.